Hello, my name is Jimmy Costello from the NX Product Marketing team, and today I'm going to go over how using Performance Predictor can help you to determine the displacement and stress that will result on your part when it is exposed to different forces and constraints. We're beginning with a coffee machine, and I have already loaded an inner assembly containing a coffee tamper. The reason we are using this part is so we can examine the stress and displacement on the part's head when the coffee machine is used. After making the tamper our work part, I'm going to open up Performance Predictor so we can begin to run some testing. To start, we can select New Analysis from the upper left-hand corner. When this is done, we are prompted to name our test and additionally select our resolution for the testing performed. Fine resolution will produce a more detailed result, but may take a bit longer to run. Once our test is ready, we can hit OK, and our test will populate in to the Performance Predictor navigator, which can be found on the left side of the screen. With our new analysis started, the next thing you may notice is the large number of sections under our test in the navigator. For each section with a red asterisk, there must be at least one variable selected in order to run and produce results. The first section I'm going to fill out is our analysis body. For this field, I'm going to choose the entire body of our part. It is important to notice that this is where we can choose the material of the part. You can either select a material of your choice or opt to use the material that has already been defined in your assembly previously. This is an excellent way to explore the impacts of altering your material makeup and see the effect it has on the product's structural integrity. After this, the next part of our test is determining our product's constraints. Here you may notice there is a wide number of constraints to choose from, ranging from fixes, pins, and sliders. For this, I'm going to fix the underbody of the tamper's head so we can specifically examine the head without other moving pieces. The last variable we need to set up is our analysis load. You can choose the load type, select the body the load will be placed upon, and the direction it will come from. I'm just going to select the circular face on the head. We can now run our test. To do this, you select Show Result, and our displacement and stress values will be generated. Additionally, there is also a color-graded scale to show the stress and strain created across the part. This is a great way to assess where the part will be tested most when the product is in use. The last thing I want to point out regarding the setup of Performance Predictor is the Show Loads and Constraints tool at the top towards the center of the screen. When this is selected, a visual representation of the loads and constraints will populate in. This is useful in scenarios where you may want to take a screen capture to show off the results of your tests. Because these visual representations can get cluttered quickly, we can simply click once again on the tool and the representations will disappear. In conclusion, overall, in this video we explored how to set up a Performance Predictor test and select the variables necessary to produce strong results. When setting up the test, we looked at how we could control and choose the material of the part we tested. Once all of our variables had been determined and selected, we ran our test by selecting Show Result, which produced a color gradient view of our part containing values for displacement and stress. And finally, we looked at how we could control the visual representation of the loads and constraints by using the Show Loads and Constraints button at the top of the screen. I would like to thank you for your time and attention.